One time there was a man with a crazy idea because he had traveled around the world and he'd been almost from pole to pole. I don't know if he ever quite made it to the North Pole or the South Pole, but he explored wide and far. He was a weatherman. He was a meteorologist. They weren't weathermen in those days. They didn't get on the news and forecast because this was about the time of World War I, early 1900s. And he was Alfred Wegener. And as we said before, he came upon an idea. Now, in science, there are those huge, groundbreaking thinkers who are sometimes condemned for their revolutionary thoughts. There was Copernicus, who said, I don't think the Earth is the center of the universe. It may look like that from where you're standing here, folks, but I don't think we're the center of the universe. And they said, you're crazy. But he was right. And Ptolemy and all these other big thinkers. In biology, there was this monk, and he had these garden peas. And what was that all about? Who was that guy? It was genetics. Who was that guy? Gregor Mendel, Mr. Garden Pea Man. Counted those things and counted them and came up with ratios. And we still remember his name to this day. And let's see. There was Watson and Crick, who really didn't do so much of the work. They stole a lot of work, a lot of ideas from other people, but they get credit for this giant spiral thing called DNA. Even though most of the work was done by other people. They're the ones we think of. But then there was that guy that so many people criticized that said, I think things change. I think animals today are different than animals than they used to be. I think, yeah, Darwin. And he gets a lot of crap heaped on him that he doesn't deserve. And if there is something in Earth and space science in the last 100 years that has been the biggest change, it's plate tectonics. Because it ties together, why are there mountains? Why are there volcanoes? Why are there earthquakes? Why are there trenches in the ocean? All those pieces just fall into place because of this revolutionary idea. And it all started with looking at a map and saying, it sure looks like South America could squeeze right into Africa. You could kind of slide North America in there too. Now the other pieces don't fit quite so great. So if you use your imagination, and if you back it all up, you can make these other pieces fit as well. About there. Now that's not perfectly one big supercontinent, but this is paused. And where are we? Where is Ohio going to? Where is what's going to become Ohio on here? Where? Might be. How about United States? How about North America? How about South America? How about Africa? Anything look familiar? No. Okay. I'm thinking that could be South America. I'm thinking that could be Africa. I'm thinking somewhere smashed up in here. It's kind of North America. We're not too good looking. And this mess over here is going to become what? Okay, that's probably Asia, and this is probably Europe. And so really, way back, there was two continents. So this is about Pangea. Jeff? Throw something at Sean. Start that up again. Get rid of that X. Get rid of that X. All right. Fire it up again. Good man. Whoa. Man, North America, a lot of it's underwater. This is going to become the western part of the United States. There's an ocean coming in here. This ocean's going to get trapped, and that's going to dry up and leave a great big pile of salt. Anybody know where the Bonneville salt flats are? Go up to, I'm not sure what state that is. Is that Nevada or someplace out there? New Mexico? Out there somewhere. In other words, this pile of ocean gets trapped and it dries up like a bowl of salt water. What's going to happen down here? If that's South America, that's Africa, what the heck is this going to become? That's partly Antarctica. You're darn right. It's going to drop down. And what else is probably? Australia's in there too. Jeff? And is this perfect? No. Right? But is it probably pretty close? Probably. Okay, can you, Jeff, grab that and slowly back it up just a little bit, and I'll tell you when to stop. Try there. A little bit more, just a hair more. Stop. All right. Ooh, what's this chunk going to become? What's that one? Whoa, my gosh, look at it going. Bam! T-boned, Asia. What is that subcontinent? It's India. That's India. India, what's that island? Yeah. So, what kind of animals are in Madagascar? Lemurs and things like that. Where else in the world do we find those kind of animals? Madagascar and India have a lot of the same kind of animals. Can we do that again? You back that up, Jeff? Go all the way to the total beginning. And pause. You say, well, my gosh, what's that? Well, it's easy, in my mind at least, to start at Pangea. But to go before Pangea, it's pretty tough. Because I can see my present continents in Pangea, and I don't see present continents. What the experts believe is that this supercontinent break apart, they now think that happened at least 4 times. And Pangea was just the last episode of this plate tectonics business. Pretty hard to go. I mean, you have a plate, dropped on the floor, broke it, glue it back together, drop it on the floor, break it again, different places, glue it back together. Do that 4 times. Now you tell me which breaks were the first breaks and which breaks were the third break. That's pretty hard to get it all right. But I'm not shocked that it hasn't happened more than once. I'm not sure that we have all the pieces exactly where they should be. So this is before Pangea, and we think there was a supercontinent that was mostly on the southern hemisphere. All right, fire it up, Jeff. Oh, stop it, Nixon. Now, if you take zoology, talk about the history of life, how do landforms affect life? Okay.
What's adaptable?
There you go. That's a nice word to use if you're just studying evolution on zoology, which is what you go on. Okay. All right, let's be an animal 450 million years ago. Are there lots of great land spots to be living on, folks? Oh, we can live down here? Oh no, it's probably pretty daggone cold down there. So why didn't land animals evolve until later? Because there weren't a lot of good land places to be a land animal at that point in time. The currents of the ocean affect the weather. Wow, we have one monstrous ocean on the northern hemisphere. I mean, the whole weather patterns. You talk about hurricanes, they probably have massive hurricanes because they had all this wide open area to become a hurricane in. Fired up. Now we're kind of putting Pangea together. Yeah, let's stop about there. I think that's where we started the first time stop. All right, now, the question might be, why does it keep happening over and over? Well, here's the current thought. Think of this as a hot, gooey thingy. And right here we have a layer on top, don't we? And it's hot inside. Where is it going to get hottest under the surface? Where we have this landmass or out here in the ocean, which is the rest of it? Where's it probably it's going to be a little bit hotter?
Where there's not water.
Where there's not water. This is insulating the heat. So after this big landmass is there for several million years, it's getting hotter and hotter. It's like where the blanket is heaviest and hotter. And what do hot things like to do atomically? Move. They like to move faster. If they move faster, what about volume? They spread out. We call that expansion, don't we? So underneath it here is hotter, and the particles are moving faster, and they want to expand, and they become less dense, and they go what direction? Where do hot things go? Up. So underneath it here, it's trying to come up. It's trying to come up. It's trying to come up. And eventually the balloon bursts someplace. Why did Pangea break up? It was hot underneath of it. Why did it break right there? That must have just been a weak spot. It just broke where it broke. When you drop the plate, why does it break where it breaks? Might have been a weak spot.
Was equipped with a depth sounder. Now, still being a geologist at heart, he used the sounder to measure the depth of the